Welcome to another Study Session Tuesday here on the Cyber Insecurity channel. Thanks for joining us for the 7th episode of the Intro to Python series. We're halfway through. It doesn't seem possible. My name is Brent Eskridge. I was a software developer for 6 years, a computer science professor for 17 years, and I'm now a threat intelligence analyst. So what that means is I've programmed lots of different things, from shell scripts to a network server to simulations that run on supercomputers. which means I've made all kind of programming mistakes, but I enjoy helping people learn to make completely different types of programming mistakes. So feel free to connect with me on the socials. You can use !Brent in chat to see them. If you're going to connect with me on LinkedIn, please send me a note that lets me know either if you've been watching this for a while, how it's benefited you, or if you're just getting started with the series, what you hope to get out of it. So I do have a bit of a backlog on my LinkedIn, just an FYI. Work's been a little crazy with, kind of world events going on. So, but I'm going to try and work through that backlog. Before we get started, I'd like to thank our moderators for being here. We have a zero tolerance policy on toxicity in the cyber insecurity channel. We want this to be a positive learning environment for everyone, and moderators are here to make sure that that happens. If you're put on a timeout or a ban, talk to the moderators about it in our Discord. Don't talk to me. I don't have anything to do with it, and I'm not even allowed to look at chat. They will do something nasty to me if I do. So moderators are not here to stifle chat. They're here to make sure you get an opportunity to learn and ask questions. I really value the questions. That's one of the things I really miss about being in the classroom is the interaction. So the more you ask questions, the happier I am. So, and you don't want someone grumpy leading the stream. So, or at least Neil doesn't. So I do welcome questions, but there are a few rules. First, ask your questions once and only once. The moderators do see your questions and will send them to me. Now, I may not answer them, right away or even necessarily in the order they were asked. So if you've got a question that I'm going to actually be answering in a minute, I'll wait until I get to that point or, something. So I'll see how that goes and do that. Second, there are some questions I just can't answer on stream. So if you've got a question with your program, it just isn't working, I can't, stop the stream for everyone when that happens. So when you do encounter a situation like that, though, feel free to jump in our Discord. We have an Intro to Python room there that you can ask your question. So if it's after stream, I'm more than happy to jump in and answer it. If it's during the stream, I think there's a few people that kind of hang out in there and will answer the questions. Very frequently, people are so great on the server that the question is asked before I can even jump in to attempt to answer it. So that's fantastic. As a quick reminder, this series is based on content from my University Intro to CS course. So it's the same content. You just don't have to take tests, take out a loan and things like that. So there's no prerequisite knowledge. Now, we are going to be building off previous episodes in the series. So if you're just starting us, there is the prerequisite knowledge of the first 6 episodes. But other than that, you don't have to come to the stream knowing anything. We use basic math examples throughout, but we've passed most of that. But we're really focusing on easy to define problems and easy to work problems. So basically problems that you could solve with pencil and paper. And so we learn about how to then implement it in a programming language. All the content is free. So I've got basically my lecture notes from when I taught this as a university course. I've got supplemental resources, so links to other books, YouTube videos, things like that may talk about a specific subject, some exercises, things like that. I know that people learn in different ways, and sometimes they have to hear it a couple of different ways or see it a couple of different ways or wrestle with it on their own to learn something. So I've tried to provide a curated list of that. It's you can find the link to the GitHub repository in chat by using !Intro to Python. So again, everything on there is free. There's also a link to the book we're kind of going through. So it's called Think Python. It's the 2nd edition for Python 3. It's a free PDF download. If you want to buy it, go ahead and you can find it at your favorite bookstore. Again, I don't have any affiliation with the author. I just think he's got a great book. And I've enjoyed using it, and I think my students in the past have enjoyed it. So let's get started. And as with every week, we are going to start off with the algorithm of the week. So I posted on Twitter yesterday to solve the algorithm, and then somehow the algorithm actually didn't get attached. So I fixed that today. So hopefully you saw that. But our algorithm is, given a list of numbers, possibly containing some duplicates, build a new list that contains only the unique numbers. So you throw out any duplicates. So I've got an example here that wasn't listed on Twitter, but you've got an idea. So I've got the numbers 1, 2, 3, 2, and 4. So notice the 2 is in there twice, that we're going to remove all the duplicates. So we just have 1, 2, 3, 4. So this one's a little bit more involved, but I'm going to simplify it here. That this is pretty much the problem to solve, right? So remember those dreaded word problems, they usually contain some extra stuff. Here we've got the example. So I'm going to just kind of use this as our problem. So remember preconditions, these are the things that are true before the algorithm ever starts. Think about sometimes they're the things that are given as arguments. In more complex programming situations, it's more generally the state of the program, whatever that means. So if you've done object-oriented programming, it'd be like the state of the object. So our preconditions are, we are given a list of numbers. Okay. And again, as we've done in previous weeks, we have to define exactly what this means. Are we going to accept an empty list? Sometimes, in computer science we do, right? And generally in life we do, right? If I have a to-do list and I complete everything on my to-do list, I still have a to-do list, it's just empty. So we're going to go ahead and allow an empty list, right? And then the post conditions are that we're going to return a list of numbers that has no duplicates, right? Now, there's a couple of things to note about this. I am not saying anything about the order of the numbers, right? So while the example showed that, we start off with 1, 2, 3, 2, 4, and I said I could have 1, 2, 3, 4, I could easily have them, 4, 1, 2, 3, something like that. So I'm not stating anything about the order of the items in the list. So that's important. Now, it may so happen that we keep them in the same order, but given our definition here, we're not required to do that. So again, that's one of those things that as you get more experience programming, you start to learn what exactly is part of what we call the contract. What do you have to abide by? All right, so let's start looking here. So we can do just a quick, easy out, right? Where we could say, step 1, if the list is empty, return empty, right? So we're done, right? I've removed all the duplicates. There's nothing in there, so we're just good to go, right? So that's an easy out. So the next thing is we're going to return a new list. Let me change this, that we need to make sure that this is a new list. So we're going to actually have to create this new list. So let's create a new list. So that's going to hold all the non-duplicate numbers. Probably not the best explanation, but we're working through it here. So we've got that. Now we need to go through all the numbers in our original list that were given and start adding them in if they're not already in our new list, right? So if you remember, we're going to talk about this in more depth today, but usually the phrase we use, or the term we use to go through this, is called iterate. So we want to iterate through all the numbers in the given list to differentiate it from our new list, right? And so now we can go here and we can say, well, the first thing we want to do is we add it, but only if it's not in the list, right? So we can just say here at the moment, if the current number is not in the new list, then add it. And then we can say otherwise, go on to the next number. All right, so we're going to walk through them. If the current number is not in the new list, so the very first time we go through here, there's nothing in our new list, or 1, yeah, it's not in there, we can add the 1, right? We get the 2, it's not in there. The 3, the second 2 is going to say, yes, it's in there, so we'll hit this second step, and we go on to the next number, and then we can say 4, return the new list, right? Now, a lot of my students, when we first start working on these algorithms, will stop here and call it good, right? And they're right. This is a complete algorithm. However, there's some important details missing. And this is usually, where I pull out the red pen and, let it flow freely on a homework or an exam or something like that. We've kind of assumed that we know how to do this, right? And we'll find out when we get later on Python. Python does this really easy. But what if it doesn't, right? What if the programming language you're using doesn't have a way to do this easily? So we've kind of assumed that the computer knows how to do this. But, we can't always assume that sort of thing. So what we're going to need to do is we're going to have to develop another algorithm to check to see if a number is in a list, right? So I've got it prepared here. So we're just going to check to see if a given number is in a list. So our preconditions are, we are given a number and a list of numbers, right? And actually we could generalize this, when we talk about abstraction, to any item, piece of information, but we'll stick with numbers here real quick. And so the post conditions are, remember, our Booleans that are true, false. So we're going to return true if the number is in the list, otherwise false, right? So let's go back here. Is this going to do it? We need to check to see if a number is in there. Yes. Now, the challenge here is we say if the number is not in the list. So we can go back and forth, but if you remember from a couple episodes ago, we have our logical not, so we could just check to see if it's in the list and then not it, right? Because it's easier to ask, is a number in a list? That's probably something you're going to do more common, right? And a good rule of thumb when writing programs, make the common things easy and the uncommon things possible. So I'm more likely to ask if an item is in a list. So that's the common thing. So I want to make that really easy. It's uncommon to say, is it not in a list? And so I'm going to make that possible, meaning I can check to see if it's in the list and then not it, which reverses it, right? So say that again, make the common things easy and the uncommon things possible. So we're going to go through here. So a couple of steps. Now, you remember from a previous episode, we've got a success or failure here. So we need to decide what we're going to start off with. What's the default? Are we going to default to success that we found it? Or are we going to default to failure that we didn't find it? And it's really dependent on the problem. In this case, we're checking to see if a number is in the list. I'm going to default to failure, which means it's not in the list until I run across it. Because the nice thing is, if it's the first item in the list, I can return right there and I'm done, right? If I've assumed success, then I have to go through the entire thing and make sure it's not in there, right? So I am going to start off, and I'll put it in here that I'm assuming failure. But basically what that says is I'm going to create a variable that says we didn't find it, right? So false. Then I'm going to iterate through the list. So we talked about that before. Iterate through the list of numbers. And then I'm going to check here, does the current number in the list match the given number? If it does, success, we found it, right? And so what we can do is we can quit looking through the list, and then we could go otherwise it doesn't match, and we have to go on next number in the list. And so then we just return our success or failure, right? Whatever the value in that variable is. So while this was a perfectly good solution, we had an assumption right here that the computer knew how to do it. And so unless you know your tool and your programming language can do it, you really need to go through this part of the problem to solve it. So I frequently see this with sorting and that sort of stuff, where someone new to programming will get the big picture but miss some of the small details. And unfortunately, some of the small details are the ones that will drive you mad for hours while you try and figure it out. Okay? So this was one algorithm, but we really needed to dive in and do 2 algorithms to solve it. Okay? And again, you'll see when we get to lists that this Python has something built in that makes this really easy. Okay? All right. Well, before we dive into Chapter 7, there was a question in the Discord this past week that I really wanted to touch on. So someone, I don't remember the name, asked about what is debugging code. So I mentioned it last week. So this is the code from last week where we were summing numbers iteratively. And I mentioned about test code, debugging code, and scaffolding and some things like that. And I wanted to make sure everyone understood. So debugging code or test code, those sort of things, that's code that you're going to write as you develop a larger piece of software that isn't really intended to solve the problem. It's to help make sure you're on the right track and your code is working properly. So for example, in this situation, this print statement and this print statement was test code, right? You can see I've commented it out here because once I got it working, I didn't need this code anymore. Sometimes you can delete it. If there's a lot of it, sometimes do it. If it's in a particularly nasty part of code where I may need to do this again, I'll keep this in here. When you get to be a more experienced programmer, instead of print statements like this, you'll use a logging utility. Log4j was a big one that was in the news in December because they found a vulnerability. And the thing that made the vulnerability really problematic was that log4j is used everywhere because it's a great logging utility. And so the idea is you can log these things out, send them to a file. That's what I've used in the past when I use Java. So this is kind of like baby steps, or if you're doing quick and dirty code, you use this. You can use logging statements in more production-like code. But I want to point out that this is very common. You want to be writing this as you write code because it's a lot easier to do that. Write a little bit of code, test it, write a little bit of code, test it loop when you've got this debugging code in there to help you. So I wanted to make sure to mention that. And please ask questions if there's something I allude to that you don't really have an idea of what I said, or when I explained it I wasn't particularly clear. All right, so we've already talked about iteration before. So we've talked about for loops back in Chapter 4 when we were doing the turtle graphics. So we said that's iteration. And then a couple chapters ago we talked about recursion, where it's a function that calls itself. So we're going to dive into some iteration some more. But I do want to make a couple of points here that I'm sure everybody's probably picked up on, but I want to be intentional and not make assumptions because, people come from different backgrounds and they might not have caught this. So there is no limit to the number of times you can assign a value to a variable. So I can say here that I want to just keep on changing the values of the variable a, right? I sometimes describe it, think of it as a bucket, and you're shoving values in here. So I start off with a 2, then I start off with a 4, then I start off with a 5, right? And every time I shove the value in there, I pretty much, it replaces what the previous value is. So you can assign things multiple times. Now, this particular line here, where I'm setting B equals to A, there's a couple of different interpretations you could have here. One would be, I just copy the value of A and put it in the variable B. So it's got the copy, so when I change the value of A here, B still has 5 in it, right? Or there's another one where I could say, now B refers to the same bucket or the same place in memory as A, so when I change A here, I also change B. That's not what's happening. This is basically, we are just copying the value, all right? So we'll talk about later, there's programming languages, C and C++ can do a pass by value or a pass by reference, and we'll kind of talk about that as we go. But for all practical purposes here, when we do this sort of thing, we're copying the value out, which means if I go back and change the variable, in this case A, later, it's not going to affect B at all. All right? And I have mentioned this before, but I want to make sure that everybody gets it, and I want to be intentional about it. So very often, we want to update a variable. So usually, so for example, I have it here, and we want to increment the value. So this is called incrementing. If I want to subtract a value, that's called a decrement. All right. So I need this x equals 0 here to make sure that this variable is defined before I use it. So this is very common in programming. Now, it's not as common in Python as it is in other programming languages, because other programming languages need it for how they work with lists and arrays and things like that. Python has some functionality that you don't need it as much. So you'll see this a lot in programming languages. And since it's so common, I showed it to you, or I showed it on screen. This is equivalent. This is the lazy programmer way of doing it. Other programming languages allow you to simplify it even more. But this is also a decrement, and this is also an increment. Right? You'll see these shortened, abbreviated ones more often. Yes, we're lazy programmers. You know, I don't want to type that X in an extra space. But it also is very common. Just it's a programming idiom, IDIOM, an idiom that's it's just the way it's done. All right. So you'll see that as we go through. All right. So let's talk some more about iteration. So when we talked the first time, we talked about a for loop. All right, so the very first one was a for loop. This is what we call a definite loop. All right, when you start the loop, you know before you get going exactly how many times you're going to go through the loop, right? You're definite. Well, we're also going to talk tonight about a while loop, and this is called an indefinite loop. Okay, it's not an infinite loop. That's something else we'll talk about in a minute. An indefinite loop here is when we get started, we might not know how many times we're going to go through it, right? So it's like a program that says, you know, a guessing game, right? Guess a number between 1 and 10. Do you guess the correct one, right? And then it keeps on going until you get the correct one, right? So I could guess it correct, or I could, you know, not be paying attention and just repeatedly guess the same number over and over again and never get it. So that would be an indefinite loop. Now, I'm going to be completely honest here. I programmed for a long time before I, you know, really started discussing even the concept here of a definite loop and an indefinite loop. You don't need to know this to be a good programmer, right? So just put that out there. However, once I really started looking at it here, and I had to teach it, and I got more familiar with it. One thing it does is it helps you when you're trying to analyze a problem, right? Just look at it and say, is this a definite, indefinite? Do I, kind of understand the problem in my solution at a little bit better level? So now, most times, can you write a loop with a for loop? Yeah. I mean, pretty much all of them. Can you do it with a while loop? Yeah. So you can use one or the other. They're equivalent. So there's nothing really wrong with using a while loop, or someone else would have used a for loop. However, there are certain things that a for loop is easier to write code for, and the same thing for a while loop. So I want to just kind of throw that out there, that they both have their strengths and weaknesses. Learning when to use which one is going to be beneficial, and that comes with experience. All right. So we've when we did recursion, we did a countdown, right? So 5, 4, 3, 2, 1, blast off. So let's do it again, but this time with a while loop, just so we can see what's going on, right? So I'm going to have define a function countdown, where I've got an n. And so the idea is I'm going to give it like, I'll put a little comment here, to do, and then I do countdown of 5, and the code will go 5, 4, 3, 2, 1, blast off, right? And so what we're going to do is we're going to loop through, and we're going to go through. And so if we want to do blast off when we hit 0, then what we really want to do is we want to, so I'm going to go ahead and use iterate through the numbers n to 1, right? I want to print out 1, but I don't want to print out 0. So I'm going to iterate through the numbers n to 1. So I can say, which means I want to stop this when n is less than 1, right? Or I want to continue it while n is greater than 0, right? And so basically the formulation of a while loop here is I'm going to do while. So while this evaluates to true, go ahead and execute the body of the loop, okay? So the loop body will execute while n greater to 0 is true, right? So while that's true, it will execute, which means at this point, I just want to print out n. Now, one of the nice things about the for loop is, we said I wanted to do range from, 1 to n, whatever, and it would automatically change the value. A while loop will not change n. So what we have to do is we have to update n on our own here. So in this case, I'm going to decrement 1. All right, so this is going to go 5, 4, 3, 2, 1. And then whenever n is not greater than 0, so when it's equal to 0, it will not execute this loop. So this loop will continue to execute until this evaluates to false. All right, and so once that happens, we just want to do a print blast off. All right, so let me save it here real quick and run it, see if it works. All right, so we got 5, 4, 3, 2, 1, blast off. Now, let's check this here real quick. If I do -1, what's going to happen? I want to pause here for a second, let you think about it. What do you think is going to happen? And so I could just run the code and see what happens. But what I want to do is I want to make sure I understand what's going on and I understand my algorithm, and I want to predict it. Because if the code does something different than I predict, then there's a problem somewhere. It could be my understanding, it could be in the program. All right? So while n is greater than 0, well, -1 is not greater than 0, right? So it won't even execute the while loop. It's just going to blast off immediately. All right? So that's an important thing here, is that there is no guarantee that you will ever execute the body of a while loop. If it evaluates to false the very first time it comes through, it's going to skip over that while loop body and never execute any of it. All right, so let's test it here real quick and see what works. You see we've got a second blast off from this. All right, so important thing, while loop, there's no guarantee it will execute. Okay, now there's another way to write this, and I want to show this because this is probably the way you're going to see while loops written. This one, this is probably one that it's easier to write as a for loop. It doesn't really fit the definition of an indefinite loop, right? I know I'm going to execute it in times when I start. So, it really doesn't fit kind of the rule I set out before. It's a good simple example, and we've used it for some other things, so it's good to see how it compares. But let's look at it a little bit different here just to see. So it's going to have the same functionality, so the same end result, but we're going to get there a little bit different way. So I'm going to just call this alternate here. Now, we're still going to iterate through, but rather than do the test every time, I want to set up a variable to say, am I done? Right? So I'm going to start off with false here. We're going to change it. And so then I can say something like, while not done, right? Then we can print out n, and then we can do our decrement here to update n, and go on, right? Now, we're going to have to recalculate done, right? And so we need to update done. So done, it's going to be the same thing we had here before. So done is equal to n less than or equal to 0. So it's the opposite. It's the same sort of thing. So I am done. This is going to be true when n is less than or equal to 0. So remember, so you can kind of see we're flipping the question here. I'm checking to see when I am done, right? And so I can do that exact same thing up here. Instead of defaulting to false, I can just say, am I done? All right, so let's run this here real quick, and then I'll go explain why I did this, why I made things more complicated, other than just, programming, half the fun is making things complicated. All right, so, all right, so it's got the same output. So why would you do this sort of thing? Well, in this case, done is a Sentinel value, or Sentinel variable, all right? So a Sentinel is kind of one that, stands out. You think of like on a castle, stands guard and standing there watching. So in this case, a Sentinel variable is this variable that basically decides whether or not this is true. Now we've got a not in front of it that switches it, but that's because it makes it read easier, right? And so the idea here is we say while it's not done, because that's a lot easier for me to read and understand than saying while n is greater than equal to 0. It means the same thing when we dive into it, but this code is a little bit easier to read. Now, this is a simple problem. Probably didn't need to do this. But when this, done criteria has lots of details in it, that's where this sort of thing really shines. So for example, think of everyone always hates having to change the password where there's really obscure rules, right? It's got to be 12 characters, not the same as your previous 5 passwords, and it's got to have an uppercase and a lowercase and a number and a symbol, and not be, password and things like that, right? So there's multiple criteria. So what we could do when we write code to check that is we don't want to put all of that criteria here in the while loop, right? We do that because that'd be really cumbersome. And so what we do is we just store the success or failure in a Sentinel value. And so we basically are saying, while it does not pass our criteria, keep asking for a different password. But once it passes our criteria, which in this case could be like 6 or 7 different criteria, then we'll accept it. So that's where the benefit of a Sentinel value really comes in. And, you can see a while statement really shine is, I don't know how often I'm going to do that. There's multiple criteria. It's very complex. A for loop is really good when I just need to run through a series of numbers, right? Or a particular sequence or something like that. A while loop is good where I've got all of this different criteria and I've got to wait to see, did it pass this criteria? Did it not? Things like that. So that's really where the definite and indefinite loops really come into play, right? So that's hopefully that helps you. You kind of get a little bit of an idea where a while loop can be used. So one thing to note though, if I don't do this correctly, then I can have what's called an infinite loop, right? So if I did this a little wrong, right, I could have a loop where it never evaluates to false, right? So that's called an infinite loop. Let's see. Let me write just one real quick to do. So I could say x equals 42, and I can say y. Oh, this would be a good way. We'll do this better. If I forgot to update in, right? If I forgot to update in and just did it like that, it's going to keep on printing 5 forever because it will never not be greater than 0. It's 5, right? 5 is always greater than 0. And so that's what's called an infinite loop, right? So put another comma down here. An infinite loop is a loop, I'll go ahead and call it a while loop where the test is never false. Okay? So you can't do it in a for loop like we've got it here. You can have them in for loops in other programming languages, but the way we've got them here, it's not going to work. But so we can say a loop. I'll go ahead and remove the while. Someone will complain to me. So a loop where the test is never false, right? So those are generally bad. Now, there are situations where an infinite loop is actually intended. So one example would be if you program a web server or a server that accepts network connections, you always want to be listening for a connection. You never want to stop. There's never an upper limit of, I've served 10 web pages, I'm done for the day. So you have an infinite loop, but it gets around those the infinite loop in other ways, so it doesn't go on for forever. It actually can stop. So there are situations where you want an infinite loop, but pretty much 99% of the time when people are programming, they don't want an infinite loop. So make sure you understand the difference between an infinite loop and an indefinite loop. If you were my students, I'd say be on an exam, but you're not, so just remember it because it's important. Okay? All right. So we've got the while loop, and sometimes, we can quit out of the loop by just making this false, right? But sometimes we may need to get out of it before that. And you can even do this within a for loop, all right? So there's something called a break statement. Now, before I go on, I want to give a warning. There are a number of things in programming languages that people abuse because they don't know any better. They're ignorant. And that's, ignorance is not an insult. It's just you don't know. All right. So you won't have an excuse after this because I'm telling you. A break statement allows you to quit out of a loop early, right? So in a for loop, it could be in the middle of it. A while loop, it could be, I just want to quit right now. I don't want to keep processing anything like that. All right. So, however, I have seen break statements abused. So I've seen lots of code that's meant for one thing used in a completely different context because it can get the job done, right? That doesn't mean it's a good use of it. So that being said, be very wary of using the break statement. It can be beneficial, but most of the time new programmers use it inappropriately. So I would say steer clear of a break statement unless you don't know of any other way to make it happen, right? I will force myself to work and work and work to find ways to avoid using a break statement. So, but there are times it's necessary. So let me show you real quick. So let's write some code that grabs some input from the command line and then prints it back out, right? So we're going to have an intentional infinite loop. So while true, that is never going to be false, right? And so I need to get user input. And so line, this is just the line of input. And so there's the input function, and I can give a prompt. So I'm going to do just a little prompt here. And then I can say, so I want to echo the line, so I want to print it out. And so I can print out the line. And then, you know, at some point I'm going to be done, which may seem odd because it's an infinite loop, but we'll get there. And so we can say, we are done. Done. All right, so let's run echo here real quick. So I'm going to run it so I can say, oops, move this down. Hello. And so it'll echo, but it'll never quit. So I've got to hit Control C to quit. And actually, that didn't work. So it finally worked. But this isn't really a clean solution, right? I just had to bail out. So what we'd want to do is like be able to enter something special. So a special word that would say, I want to quit, like quit. All right, so what we can do is I can put a statement in here that says, did the user enter quit? Not quite quit. So I can say if quit equals line, then break out of the loop. So let's run this again. So I can say hello and then quit, and it shut down for me. All right, we're good. So I was able to use the break statement and it did. However, there's a better way to do this, right? So, you know, you could do this, and if you're just learning programming, you know, it's okay, but I don't want people to get into bad habits. So if you remember up here, we talked about a Sentinel value. We called it done, right? So we're basically checking to see, are we done? So we can do the same thing here. So let me create echo without break, right? So I'm going to do that. I'm going to comment this out. So we're going to do the same sort of thing. So continue to get input while we aren't done. So I say while not done. So just like we did up above. And then I can do the same thing I did. So in fact, I'm just going to copy the stuff here. That's what good programmers do. Copy and paste. All right. And so we get the input, we print it out, and then we go. Now, notice we didn't print out the quit. So we're still going to have to say, did the user enter quit? So if quit equals line, we're going to test something, right? Now, we're using done here, so I've got to create this done. So done starts off with false, right? We're going to default to not done, meaning keep entering strings to echo, right? So if we quit, then we want to say done equals true, right? And so we can come down here and we are done. Print done. All right. Echo without break. Now, I'm going to pause here for a second. There is a bug in this program. I want to see if you can find it here. So I'm just going to pause. I want you to look through. it's very similar to the function we have up above, but there is a code in, there's a bug in here that it's not going to work exactly the same, even though we've tried to do the Sentinel value here. All right, so let me go through, and I'm going to run it here so we can see. All right, so we've got it. I'm going to say hello and quit. See if you noticed it. All right. The error is that it printed out quit, which we did up here, and it didn't do that, right? Because we broke out of the loop before it hit the print statement. Here, we say done is equal to true, but we continue executing the rest of the loop, right? So what we want to do is we need to add in an else statement. So this is only executed if it doesn't match. So we can run here real quick. I can say, hello, quit. Now it works, right? Now, this is a little bit more cumbersome. Yes, I had to create this line. I had to make it an else statement, things like that. This is the easy way. That doesn't mean it is the right way, all right? So again, I want to impress upon you that, just because this is necessarily easy doesn't make it a good program. Now, they both function well, but this code, we spent a little bit more time on it. We were intentional about it, that this is probably easier code to maintain, right? Just because it's more detailed, more intentional, there aren't little gotchas, things like that, right? So usually I will favor a little bit longer code that's easier to understand and easier to maintain than taking the quick way out. All right, so, words of wisdom from someone that's made lots of mistakes. All right, so we've got a little bit of time. I'm going to throw in here just a little programming project game. Usually when I would do this in class, I would give students the prompt to do it and then let them stew about for about 15 minutes and do that. But I don't think Neil would be happy with just 15 minutes of me sitting here looking at the screen. I don't know. It might be preferable to what the current thing. But we're gonna go with the assumption he wouldn't like it. So we're going to implement the guessing game, right? So the choose a number between 1 and 10 and go through it. So I'm going to introduce a couple of things you haven't seen before. But the idea is you know how to play this game, right? If I sat you down, hopefully most people know. If not, it's pretty simple. But it's, guess a number between 1 and 10. I guess 5. You either tell me it's too high or too low, or I got it right, right? So, and then I keep on guessing until I get it right, or you get tired of me guessing, the incorrect number. So it's pretty simple, right? If I were to ask you to do it with someone, pencil and paper, that sort of thing, you could do it. So the challenge here is, how do we put it into code, right? So let's talk about it. We're going to create a function, start guessing, right? And I have a low number and I have a high number, right? So let me do an example of what it would be to run, right? So start guessing. So I want a number between 1 and 10. Now, the important thing here is low and high is inclusive, which means it could be 1 or it could be 10. So I don't want to restrict it to 2 to 9. 1 to 10 is a valid number, right? So the program is going to have to start off by randomly guessing a number, right? We haven't talked about how to do that yet. I'll show you here in a second, right? Now, the next thing is we have to prompt the player to guess, right? Now, we're going to have to do this a lot, right? So we're going to have a loop. And so we're going to continue or repeatedly ask the user for a number, right? So we don't know how many times we're going to do it, right? So we're indefinite. So it's going to be a while loop, right? So I'm going to go with the while not done, right? So we can do that. Now, if we're assuming not done, that means we're going to have to default to initially that we're not done, right? So default to not being done, which means done is false, right? So because I not it, it turns to a true, so we're going to keep on going, right? So we're going to repeatedly ask the user for a number. So here we ask the user for a number, and then we need to check to see what it is, right? Check the number. So we could do this in a couple of different ways, right? We could check to see if it's exactly it first. We could check to see if it's high, low, whatever. So it's kind of arbitrary, but let's just go check. So is the number too high, right? Then we could say otherwise is the number too low. And if it's not too high and it's not too low, it's just right. So otherwise, the number is, they got the number right, right? Number right. Okay, so that's our algorithm here. So how do we guess for a number? So we've got a guess as input, and we say guess a number. Now, if you remember back, we talked about what kind of data type is this return, right? It can be anything I type, so it's going to be a string. So what we need to do is we need to turn it to an integer. We're going to restrict this to integers. I don't want to mess with floats, all right? So what I can do is I can take the input from there and just wrap it in the function int here, and it'll turn it to an integer, all right? So I'm going to go ahead and up here real quick and say I have a chosen number, and I'm going to do it to 42. All right. So I've randomly chosen a number. So then I'm going to check the number. Is it too high? So what I need to do is I need to say if the guess was larger than our chosen number. Yes, right? So if the guess is larger than chosen number, yes, too high. And then remember, this isn't just an else because we're going to do a test here. So I'm going to do elif because we're too lazy to actually spell out else. We check to see if the guess is less than the chosen number. Yes, too low. And then the last one here is else just right. Okay, so let's start filling in some of these. So we want to print out too high, right? We don't need to do anything else here. We want to print too low. And then if they got it, then we can say print correct. Oops. Correct. And then since they got it right, done is equal to true. So we will quit. All right. Now, notice we're not done yet because this is ignoring this low and high. We're going to deal with that in a minute. Okay. I want to make sure that this part is working correctly. So I'm going to go ahead and run it. So I'm going to comment out the echo part because I don't want to go through that every time we run this. So we've got it. I'm going to guess a number, 5. Remember, our number is 42, so that's too low. If I do 50, it's too high. And if I do 42, I got it correct. All right. Now, so I haven't proven this works, but I'm confident that this part of the code works, right? Now I need to randomly choose a number, right? Well, Python has a library called random that allows us to randomly choose numbers. So, and I'll explain it here in a minute. So I'm just going to go up here and say import random. Now, computers don't actually, for the most part, generate random numbers, right? There is no way to just randomly come up with a number. So they all use algorithms. I know one of the best ones I've used for research where it has to be a really good random number is Mersenne Twister. The idea is it's an algorithm that generates numbers that are distributed across a range and they look random, but they're not. And so what it does is it starts off that sequence with what's called a random seed. And so what you can do is random.seed. This is where you set it up. And some people will do it based on the time. They even try and do things like based off of input on a microphone, something like that. And so you set this random seed so it kind of sets up the algorithm. And then you can do rand int and give the low and the high number. All right. And I'm going to cheat here because I don't want to guess for a long time. We're running out of time. So I'm going to just say what the chosen number is just for our purposes here. Obviously, if we were wanting to play a game, we wouldn't want to do this. But I want to make it easy to guess. All right. So again, we're just going to choose a random seed. Now, the thing is, if I choose the same random seed, it's the same random sequence every time. So I'll show you here in a minute. So it's going to choose a number between 1 and 10, and then we can go. So it's the number 2. So if I do 5, it's too high. 1 is too low. I can do 2, and it's correct. Right? Now, even though this was random, if I run it again, you'll see it's 2 again. Right? If I were to change this to a different random seed and run it, well, of course it's not going to switch on me. There it changed, right? 10% chance it would pick the exact same one, and I got that. I should go to Vegas. All right, so you can see it's got a different number. So again, you know, kind of this was extra for free tonight. But if you ever need to do a random number, you can. The important thing here is we did a while loop. We used a Sentinel value to check to see when we were done, rather than doing a break and things like that, because I have no idea how many times I'm going to go through this. Okay? So that's all I've got for tonight. See, I've got one question. So if you've got another question that's kind of popped into your head, go ahead and type it now, and the moderator will send it to me. DuoQ has DuoQ Life has a question. What IDE do you recommend for Python? You know, there's the sarcastic answer of Vim, but that will start internet wars. Sublime, it all depends. If you do just light, you know, programming, I find a text editor is really good. If you're going to be doing some in-depth stuff, then do a full IDE. I've heard PyCharm is good. I haven't used it that much myself. I've used it a little bit, but not enough to do it. Most of my time in Python has either been in idle here, which is no frills, or a text editor. So my first programming IDEs were all text editors. And so while I love a great IDE for when I do Java, because it really helps with variable names and things like that, all of my Python work has been quick and dirty. I mean, it comes out to be some long scripts, but I do that, code a little bit, test a little bit, code a little bit, test a little bit, where I haven't really had the need to use a full IDE. Because I've been doing, you know, some other things where it's not really that necessary. So, you know, I would say if you're starting out, go with PyCharm, depending on how you're wanting to use the Python script. So, but for Java, I historically used Eclipse, but that's falling out of favor for NetBeans. But I kind of stopped programming in Java a lot before I needed to switch to NetBeans. So there's a number of good ones out there. So, you know, kind of whatever floats your boat, you can try, see if one fits better for you. I know a lot of people, it's kind of a personal preference thing. So like the internet wars on, you know, is Vim better than some other text editor? So I don't want to go into that. So I've used a lot of them. All right. Well, I don't see any more questions. So I'm going to end the stream there tonight. So I do want to thank you for joining us. So we're over halfway through. So we'll start chapter 8 next week. We're going to start diving into more of data structures, which is a fancy computer science way of saying we're going to start figuring out ways of storing data and how do we store it more efficiently and things like that. So I don't know that we'll quite get there in Chapter 8, but we're going to start doing that. We're going to start messing with some strings more. I think Chapter 8 is a lot more on strings, 9 is strings, and then we hit the data structures. But we're going to be focusing on data a lot more now that we've gotten all of the things like while loops and if statements and stuff like that. So, if you want to come prepared, make sure you read through the chapter. If not, I'll cover everything. Don't forget to follow me on Twitter, and hopefully the Twitter post will be right this week and actually have the algorithm. And if you ever have questions, please hop in the Discord. There's always someone ready there to help you. So thanks, and have a great evening.